Picture yourself standing on Venus, a world that seems alive but every breath is trying to kill you. The ground beneath glows with a dull, suffocating orange, and the sky above mirrors the same relentless hue. Everything, the rocks, the horizon, the light, is drenched in a hellish amber haze. The heat is unbearable, 475 degrees Celsius, about 887 degrees Fahrenheit, hot enough to melt lead. The pressure pressing down on you, equivalent to being crushed under a kilometer of ocean water, about 0.62 miles. And the clouds overhead, the thick, endless shroud that hides this nightmare from the rest of the solar system, they're made of sulfuric acid. This is Venus, not the serene Earth twin we once imagined. For decades, scientists sold us a fantasy, a gentle, cloud-wrapped sister planet cozy in the sun's habitable zone. In the mid-20th century, some astronomers pictured a warm, wet paradise lurking beneath the clouds, swamps, humidity, maybe even life. The Soviet Union believed it so much that their early probes carried instruments designed to find water, hoping to uncover a second Earth. What they actually found was a world that destroys everything it touches. So why is Venus the deadliest planet in our solar system? The answer isn't a single thing, it's everything working together, as if the planet is actively hostile. Let's start with the atmosphere, the first thing that would kill you. Venus is wrapped in a carbon dioxide blanket so thick that surface pressure reaches 90 times Earth's. To visualize that, imagine diving roughly 900 meters, about 0.62 miles, under the ocean, then multiply that sensation by 10. No human could survive for even a second. Your lungs wouldn't just fail, they'd be crushed flat. This atmosphere doesn't just press down on you, it crushes you from all sides, like being trapped inside a tightening vise. And that's only the beginning. The carbon dioxide traps heat. Sunlight reaches the surface, but the heat radiating back can't escape. It's the ultimate greenhouse effect, runaway and unchecked. Venus now burns at a constant 475 degrees Celsius, 887 degrees Fahrenheit, even hotter than Mercury, despite being millions of kilometers, millions of miles farther from the sun. Mercury has almost no atmosphere. Venus has far too much. Deadly heat isn't about distance from the sun, it's about what the atmosphere does with that energy. On Venus, the temperature is relentless. There's no nighttime relief, no cool poles, no breeze of comfort. Heat radiates from the ground constantly, like a kiln running for billions of years. A lead bar left there would slowly melt. Tin and zinc wouldn't even survive. And above the surface, you might think the clouds offer a break. You'd be wrong. Venus's clouds aren't water vapor. They're made of concentrated sulfuric acid, the same chemical in car batteries, but far stronger. They form a thick, unbroken layer, reflecting most of the sunlight and hiding the inferno below. From space, Venus shines like a flawless pearl, but beneath that pearl, a furnace laced with acid rain. And that rain is more terrifying than it sounds. On Venus, rain never touches the ground. Acid droplets fall from the thick cloud layer, but the air is so hot that they evaporate before reaching the surface. Scientists call this phenomenon virga, a relentless loop of acid that rises, condenses, falls, and disappears again over and over. Then there's the wind. Near the surface, it barely moves, about half a meter per second, about 1.6 feet per second. On Earth, that's just a gentle breeze, barely enough to stir a leaf. But Venus's air is 60 times denser than ours, so even that slow wind packs a real punch. Higher up, the winds go wild. At the cloud tops, they race around the planet at over 300 kilometers per hour, about 186 miles per hour, circling the entire world in just 4 Earth days, even though Venus itself takes 243 Earth days to complete a single rotation. Scientists call this super rotation, and despite decades of study, they still don't fully understand what drives it. Venus's rotation is another oddity. Almost every planet spins counterclockwise, but Venus spins clockwise. If you could see through the clouds, the sun would rise in the west and set in the east, but you'd be waiting a very long time. One day on Venus lasts about 117 Earth days, and that's longer than a Venusian year, which takes 225 Earth days. Time itself feels twisted on this world.
Its slow backward spin also affects the planet's magnetic field, or rather the lack of one. Earth's magnetic field protects us from the sun's charged particles, but Venus spins too slowly to generate this shield. Over billions of years, the solar wind has stripped away any water the planet once had, tearing hydrogen atoms from the upper atmosphere and scattering them into space. The evidence is in the chemistry. Venus's atmosphere has 100 to 150 times more deuterium than Earth. Heavy deuterium remains, but light hydrogen escaped, a silent fingerprint of oceans that once existed and were slowly erased. Billions of years ago, Venus might have been a watery world, not unlike early Earth. But as the sun brightened and volcanic activity pumped carbon dioxide into the air, the temperature climbed. Oceans evaporated, water vapor trapped more heat, and the cycle fed itself. Eventually, all the water was gone, baked into the atmosphere, and whisked away by solar winds. Venus became a world locked in permanent thermal runaway, a planet that literally cooked itself alive. For decades, scientists debated whether Venus was geologically dead. That debate ended recently. In 2023, Robert Herrick at the University of Alaska Fairbanks revisited radar images from NASA's Magellan spacecraft. He compared photos of a volcanic vent near Mont Mons, taken 8 months apart. In February 1991, the vent was a small circular crater under 2.5 square kilometers, about 0.96 square miles. By October 1991, it had doubled in size and was nearly full of lava, a direct sign of volcanic activity. In 2024, an Italian team led by David Sulcanese discovered new lava flows in 2 more regions. Venus may erupt like Earth. With over 80,000 volcanoes, the most in the solar system, and some still active, volcanism keeps feeding the deadly atmosphere. Eruptions release carbon dioxide and sulfur dioxide, which on Venus doesn't get washed away. Instead, the sulfur dioxide rises, forming the thick clouds of sulfuric acid that shroud the planet. Volcanoes act as chemical factories, fueling the toxic sky. We know this thanks to daring machines sent to Venus's hostile environment. The Soviet Venera program, running from the 1960s to the mid-1980s, was a marvel of engineering. Early probes were based on wrong assumptions. In 1967, Venera 4 was built to withstand 20 atmospheres of pressure, but it was crushed at 27 kilometers, about 17 miles, above the surface. Subsequent probes fell faster with smaller parachutes, yet both imploded 11 kilometers above the ground. Venus had claimed them, and it continues to challenge anyone who dares to reach it. For Venera 7, the engineers threw out the idea of a traditional spacecraft entirely. Instead, they built what was essentially a submarine in space, a forged titanium sphere strong enough to survive 180 atmospheres of pressure. The parachute failed during descent, and the probe crashed, landing on its side. Its signal was lost in static. It wasn't until a post-mission review that scientists discovered 23 minutes of temperature readings buried in the noise, the very first transmission from the surface of Venus. Later missions went even further. Engineers turned each lander into a temporary fortress against heat. Before separating from the spacecraft, they pumped supercooled fluid through the pressure vessel, dropping the internal temperature to -10 degrees Celsius, 14 degrees Fahrenheit. The probe began its journey as a block of ice hurtling into a furnace. Inside, they packed lithium nitrate trihydrate, a chemical that soaks up enormous amounts of heat as it melts. This clever trick gave the lander about 50 to 60 minutes before the relentless Venusian heat took over. In 1975, Venera 9 finally touched down. Scientists had expected total darkness, but they were wrong. The light was similar to a cloudy summer day on Earth. Images revealed sharp, jagged rocks, not the smooth pebbles they had imagined. Then, in 1982, Venera 13 survived for a record 127 minutes and sent back the first color photos from the surface. Everything was orange: the rocks, the sky, the horizon.
Venus's thick atmosphere absorbs blue and green light, letting only red and orange wavelengths reach the ground. A human standing there would see the world in permanent sepia tones. Calibration charts on the lander confirmed it. The white strip appeared orange, and the blue strip looked almost black. Venera 13 even captured the first sounds ever recorded on another planet, a low, constant hum as the thick air flowed past the lander, the crack of the drill firing, and the grinding of the bit cutting into basalt rock. 4 days later, Venera 14 arrived. One instrument was a spring-loaded arm meant to strike the ground and measure its hardness, but one of the protective lens caps popped off during landing and landed directly where the arm was going to hit. The arm hammered the titanium cap instead of the Venusian soil. After navigating millions of kilometers, millions of miles, and surviving re-entry, the mission was undone by its own safety gear. Since 1982, no camera has returned to the Venusian surface. We have rovers streaming high-definition video from Mars. We've flown past Pluto. Yet, for the planet closest to Earth, our view remains frozen in images over 40 years old. NASA's Veritas and Da Vinci missions, along with the European Space Agency's InVision, aim to change that. Venus is Earth's twin in size, mass, and composition. It sits in the habitable zone of our Sun and may have once had oceans and a climate not so different from ours. And yet it became this, a planet where the air can crush a machine, where acid rains evaporate before touching the ground, and where volcanoes still pump a toxic atmosphere in a feedback loop lasting billions of years. Venus is not just a dead world, it's a warning, a demonstration that a planet with all the right ingredients can still go catastrophically wrong. The most unsettling part? The same greenhouse physics that turned Venus into a furnace exist on Earth too. The difference is a matter of degree, not kind. When we look at Venus, we see what Earth could have been, or, if we are not careful, what it still could become. Curious to learn more? Stay tuned, explore with us, and don't miss the next chapter of discovery. Your journey starts here. Let's uncover the mysteries together.